Conditional statements, you have all experienced some sort of conditional statement in your life. It's an if-then statement. So maybe your parents said, if you get good grades, then you will get ice cream. Or if you don't get good grades, then you'll get your game taken away. So if-then statements. They're denoted by P implies Q. That's what this symbol means. P implies Q. P is the hypothesis. Q is the conclusion. The hypothesis is the part after the if. The conclusion is the part after then. A counterexample is a specific example that proves your statement false. So what happens is, let me finish my writing, that proves your statement is false. So what happens is it makes the first part true, but the second part false. And I'll demonstrate that in some of our examples here. So this one says write a conditional statement. So I'm going to take you to English class for just a second. The subject of your sentence is the hypothesis. The predicate of your sentence is the conclusion. And sometimes we have to rearrange words so it actually makes sense. So don't get stuck on if congruent segments, then segments are. So we're going to write this. If segments are congruent, you're going to get writer's cramp today. Lots of writing. If segments are congruent, then they have equal lengths. Abbreviate a little just because I can. So there's an example of our conditional statement. Segments are congruent would be your hypothesis. They have congruent lengths would be your conclusion. And that is actually a true statement. So we're not going to have a counterexample to prove that that one's false. A negation is a little squiggly line in front of P, so that's not P. A negation is the opposite. So if I said it is raining, the negation of that would be it is not raining. If I said x does not equal 7, the negation of that would be x equals 7. So we either insert the word not or we remove the word not to do the negation to create the opposite. There are 4 types, actually 5, of conditional statements, and we're going to show you here. A conditional statement, I'll give you an example. If an animal's, let's say if it's a bird, then it's a cardinal. So that's my if P, then Q. Now, is that a true statement? If it's a bird, then it... Now, when you read these, read it as if it's a bird, then it has to be a cardinal. Well, no, it doesn't have to be a cardinal. So if a statement is false, then we're able to give a counterexample. So your counterexample to this one might be, give me something that's a bird, but not a cardinal. So my counterexample would be eagle. Eagle's a bird, but it's not a cardinal. So you could list any number of birds that aren't cardinals. So you're going to keep the hypothesis true, but show me that it doesn't have to be what the conclusion says. So your counterexample doesn't have to be a complete sentence. It doesn't have to be an if-then. It could simply be, could be an eagle. And that proves that my statement was false. All right, next up is what we call the converse. The converse is just going to switch things. It's going to be Q then P. So conditional, converse. They're going to switch places. So this time we write if it's a cardinal, then it's a bird. Now, is that a true statement? If it's a cardinal, then it's a bird. I think that's true. because I've never seen a cardinal that wasn't a bird. So that's our converse statement. We switched it around to make it Q to P. The inverse. The inverse of a statement is going to be not P implies not Q. So we take our original conditional and we're just going to use the word not for those. So we're going to say if it's not a bird, then it's not a cardinal. So that kind of switches things around a little bit. If it's not a bird, then it's not a cardinal. Well, that's true. It can't be a cardinal if it's not a bird. That's the inverse statement. And our final one is called the contrapositive. The contrapositive is when we do both. We flip it and we negate. So we're going to say not Q, not P. So here's what I do. Conditional, converse. Now the inverse, we're going to go not. And then the contrapositive is going to go not and switch places. So kind of awkward there. So we're going to take the original one, we're going to switch them and negate them. And it's going to say if it's not a cardinal, then it's not a bird. And I think you can tell, just because it's not a cardinal doesn't mean it's not a bird. That's a false statement. And we could go back to our eagle. An eagle's not a cardinal, but it's a bird. So some interesting things to notice here. Notice that your conditional and your converse, or contrapositive, had the same truth value. They were both false. They're called logically equivalent. I don't know that I'll ever use that expression in class, but the conditional and the converse are contrapositive. Conditional and the contrapositive are always going to have the same truth value. And that is also true for the converse and the inverse. Those are also always going to have the same truth value. Now, sometimes the conditional is true and the contrapositive is true. Sometimes they're all true. If they are all true, I can write what's called a biconditional. Your biconditional is a two-way street. It works forwards and backwards. The biconditional is a combination of the conditional and the converse. Now, I can tell you that every definition in geometry is a biconditional. So let's take perpendicular lines. If I were to say, if lines are perpendicular, then they intersect to form a right angle. Let's flip it around. If lines intersect to form a right angle, then they're perpendicular. Well, those are both true. So I can write that as a biconditional statement. And here's what it looks like. Lines are perpendicular if and only if they intersect to form a right angle. So we have our lines are perpendicular, they intersect to form a right angle, and it works forwards and backwards. Now this if and only if, that's a lot to write. We have an abbreviation for that. It's IFF, IFF. So if you don't want to write if and only if, you can just write that IFF. So a biconditional, we only write if the conditional and converse are both true. Then we can create a true biconditional. So for a problem like this, we would not write a biconditional because the conditional was false and the converse was true. So you're going to practice writing statements like these with your P and Q and then your converse, inverse, and contrapositive. I will tell you we use the conditionals and converses a lot in future lessons. Tell whether the statement is true or false. If x squared equals 9, then x equals 3. Well, or x equals negative 3. Now some of you are going to go false. X is 3. So we would say false. The counterexample would be x could equal 3. Converse. If x equals negative 3, then x squared equals 9. Well, that's actually true. So it's possible that your conditional is false and your converse is true, or the other way around. If angle A is 60, then A is not obtuse. I say that one's true. Let's write the converse. Let's flip them around. If angle A is not obtuse, then the measure of angle A is 60. If angle A is not obtuse, then it has to be. Remember, we could put in the phrase, it has to be. If it's not obtuse, it has to be 60. I don't think so. Counterexample. 82. Not obtuse, but it doesn't equal 60. So remember, your counterexample makes the if part still true, but you proved that the second part doesn't have to be. Now for this one, we're going to pretend that the only Dallas in the world is in Texas. I know that's not true, but those of us who live here feel that way. If Beth lives in Dallas, then she lives in Texas? Yes. Converse. If Beth lives in Texas, then she lives in Dallas. Well, I mean, Dallas is pretty big, but no. Just because she lives in Texas doesn't mean she lives in Dallas. Think of a counterexample. Houston, Fort Worth, Tyler, San Antonio. So we're saying, okay, give me a Texas city that's not Dallas. Those would be my counterexamples. I'm going to go ahead and leave you some problems to practice along with your practice, because I think you have enough information to start practicing your conditionals, converse, inverse, and contrapositive.